Okay, so in the past two videos, we grabbed our data from the ChemCAD data files, and then we used regular expressions to compile a pattern to search for the lines of data from multiple data files that we saw on our GitHub site. So then in this video, we're going to employ that regular expression that we developed and create a class definition for the properties we extracted from the data files. So first, for Python to be able to recognize a regular expression, we need to import the regular expression module. Go ahead and do that. And let's say we want to store our regular expression. We want to compile it. Put it over here. Let's say we call this single props. And then we compile it. And then we can actually go ahead and copy over this regular expression here from regex 101. And then we want to make it a raw string, so we'll put that R out in front. And then so we've copied over our regular expression, but we have to remember that with it, we're doing matching for those multiple lines of data from start to the end of each line. So after the regular expression, we need to add RE multi-line. And that'll account for those multiple lines of data. So now to start matching, we go down here. And we want to bring single props pat down. And we want to find all the text in those data files that this regular expression is pulling. So, and then we type in find all text to do that. And then let's say we want to print this just to see where we're at. Let me make sure I ran this. Oh, oops. Okay. Ouch. Oh, there it is. Okay, there we go. All right, so now we have this list of the property names and their values. But what we really want is we want to be able to more easily access each of these properties and their values, so we can employ dictionaries. So for example, here, make this props. It's called dictionary props. Okay, so now we have those same property names and their values, but now it's in a dictionary denoted by this curly bracket here. But ideally, we still want to shorten all of these long property names to shorter abbreviations. So we can do that by using a new dictionary and then iterate to our current dictionary, single props, to grab the property name and value and then replace the long name with the shortened abbreviation. So we can go up here and call this new dictionary, let's say extract single props. And then what we'll do is we'll take these long names of the properties from our GitHub site, like we see here, and just give them abbreviations. So we'll start with molecular weight. Call that W. And then let's see what's next. Critical temperature. We'll call that TC. And then we have critical pressure and then volume. PC. We had critical volume. Whoops. Okay. And we'll take the normal boiling point. We'll name that TB. Okay. Then we'll take the ideal gas heat of formation, and then the Gibbs formation. We'll call this heat formation, ideal gas. Then we had the Gibbs formation. And then lastly, we can just take this heat of vaporization here. And this heat of vaporization is at the normal boiling point, so we'll go ahead and denote that as such. HVAC, put NB for normal boiling point. Okay. Now, just for sake of seeing everything at once, let's enter these. Okay, so now we have this new dictionary called extract single props that has the longer names of the properties and their abbreviations. So now
here, let me go ahead and shift enter that.
Let's say we want to pull a a key and a value from the single props dictionary, just this one, and then we want to grab all corresponding items. So say for a key and value, and we're actually going to pull from extract single props in the items. And what this is going to do, we're going to pull the value from extract single props, which are these abbreviations, and then the value from the single props dictionary, which is actually going to be this value here. Oh, we're going to need to define props first as a dictionary. So now we want to pull a key and value from the single props dictionary and grab all corresponding items. We're going to create a new dictionary called props. So for key and value in that single props dictionary, now let's say we want to print these keys and values separately. We can do so. Okay. So we have these names and their values, which are the keys from the single props items, but what we really want are these abbreviations here from the extract single props dictionary and then the corresponding values. So I'll type in that dictionary instead. We don't want to print these anymore. Now in this dictionary, it's the value that we want. So we type in the, then we then want the key from the single props dictionary.
Okay, so what went wrong here? Normal boiling point. Let's check. Oh, these are not capitalized. Okay, hopefully this works. Okay, perfect. Let's see. Okay. So now we see that Python is still treating these property values as strings, which are denoted by these quotations here, and we want them just as numbers. So I'm going to put a float here to just give us a single floating number. Well, that didn't do it. Oh, we just want to print props, not single props. There we go. Okay, so now we have what we've defined as single properties, but there are other valuable data in these ChemCAD data files, like some of these properties down here with equations and different coefficients. But again, this is messy data, as we can see. So to grab these and pull them over to our Colab notebook, we're going to need another regular expression. So we've already compiled that. I'm just going to pull that over from our regex site. Okay. And then we're going to create a new pattern here. I'm actually going to split this up. Okay. And then we can call this coefficient. So I want to pull those coefficients and the names of the properties that they correspond to. We'll call this coeffic name pat. I want to compile the regular expression. We want to make it a raw string again. Let me pull that again. Okay. And then for this one, we're not pulling from the start and end of each of these lines. We want to dot all instead. So I'm going to add that. Okay, and then down here we can do what we did before for the single properties. Here, and we can create coeffic name strings, we can call them, because as we saw in the data, these are strings of coefficients here. Pull over that regular expression. And again, like we did before, we want to find and match all of that text. Okay. And then let's just shift enter that. Let's see, let's print. See if we pull those over. Okay, yep. So we've pulled over all of those coefficients with their corresponding names. But like before that we did with the single props, we only want some of these properties, and then we definitely want these longer names abbreviated like we did before. So I'm going to go up here and create a new library and call it extract props, similar to up here. Right. So let's see. I'm going to start with. Okay. We want the ideal gas heat capacity. Okay. And then we'll take the liquid heat capacity. Call that CP liquid. No. And we'll want the solid heat capacity. CP solid. And then let's say we want heat of vaporization. We'll call this HVAP. And then lastly, let's say we just want liquid density. And then we can call this rho, which is the symbol for density, liquid. And then like I did before, I'm just going to tab these out so we can see. Okay, and then continuing on as we did before, we can pull the abbreviated names and the corresponding values from the respective dictionaries. So down here, I'm going to first create a dictionary that has all the long names and their values. Okay. And then I want to copy and paste this because, like I said, we're doing the same thing. But here we want to pull from the extract coefficient props. And then this is going to be the coefficients also. Name, oops, the strings. So we're going to be pulling, like I said, these abbreviations and then the corresponding values, like we see here. This needs to be over here. There we go. Oh, okay, and then So instead of converting this to a float, because these shown here are strings of coefficients, so we don't need to convert them to just a floating number. So I'm going to take this out. Okay, and come down here. Okay, so we can see we're getting these coefficients as strings, which is fine because we didn't convert them to numbers. However, we want to get them individually, so we want to split them up. And then we can do this by using a split string, which is one of Python's functions. And then maybe we also want to cut off these spaces, get rid of those, which we can do by trimming the string. So if we go up here, we can set Python up to get the values that we want by creating a decay. We'll call it coefficient values. And this is just a big container with a list of strings of coefficients that is able to very quickly append to the list. That's what the decay is. So then, like I said, we want to trim these strings and split up the values. So I'm going to create a temp. Pulling from the strings of coefficients. And that key, I'm going to strip them and then split up the values, which are separated by this space here. So we can denote that by space. And then for the coefficients in this temp, they don't equal or have the same format, we want Python to append them. And we want Python to append it as just a floating number rather than those strings. Oh, I forgot to import the key module. So we'll say collections. The key. Alright, so now this should work. Cool. And then let's say we want to print that again to see what we have. Alright, so we see now that it's split up each of the values and appended them as just the floating numbers. And I'm actually going to move this. Here. Okay, so now we've extracted the coefficients as single numbers, but in order to use them in an equation, if we wanted to later, we'd need to be able to access each of them individually. So we can do that by giving each of them a name. Let's say like maybe just a number, like A, B, C, D, and so on for each. So under coefficient values, let's say for maybe a letter and value, because we want to pull a letter for an iterable that will create a list of. We want to zip that with a value from one of the coefficients. So essentially we want to iterate through these coefficient values and zip them together as a letter and a value, like I said. So we can do that in zip. And then Python actually has a function. We import string module. Where was I? It has a string of all the uppercase letters, which is ASCII uppercase. And then we want to zip that, like I said, with the coefficient values. Then for props, we want that coefficient, which is the value, from extract coefficient library, but we want to add the letter. That way we are designating a name for each of the coefficients, and that way we can pull it individually. So let's set that equal to value. What? Oh, I'm missing a column. That'll get you, and this needs to be indented. There we go. Okay. So at this point, all of this is okay for one component, like we have water up here. But say we have a system with multiple components, and we want to get all of these properties. We need to create another dict to store the props for each of the components, which will help us, and like I said, the dict helps us append faster, especially when you're having multiple components in a system. So above all this, we're going to put all of this in a new dict. We'll call it props dict for properties. And then at the end down here, we're going to need to append all of the properties we took for one component to the outer list. Okay, I think that's right. Said append properties. All right, that worked. now we've appended the properties for each component. Well, I guess we should go ahead and add components. Let's say we have, really pick any of these. I'm going to go with ethanol like I had before. And we'll just add iso. I'll run all these. So we've appended with this, we've appended the properties for each component to one side of the list. And this is designating a two-sided list. But we want to append them to the outer loop here. So at the end, say property and the props to key. Range values, numpy array. Comp and props to key. Oh, and no, using numpy, so let's go ahead and add that too. Okay. Here, what happened? Needed to go a little further. Let's try. All right. So now all of this becomes the initialized methods and a class definition. And so we can go ahead and create the class now for these properties. And it's class of props. And then we'll need to indent all of these in, but we needed to initialize first. So let's say define init need a self components, and then we'll define self comps as those components. Okay, and then like I said, we got to tab all of this in to fit under the class. What happened here? Oh, I think this is supposed to be the rounded, or the parentheses. Let's see. And then finally down here we can set an attribute of the self, which is the components, the properties, and the values to each object in the class. And there we have the class definition for all those properties.